Assalamualaikum and good morning everyone. We would like to present our project entitled Online Light Level Monitoring System. Our project focuses on developing an IoT-based system that can monitor ambient light intensity in real time using an ESP32 microcontroller and display the data through an online dashboard. Our group members are Aina Khalida binti Muhammad Noor, Farah Nabila binti Maidin, and myself Siti Nourisha binti Kabra. Before explaining our project, let me briefly introduce what an online light level monitoring system is. This system is an Internet of Things or IoT application that measures the surrounding light intensity using a light-dependent resistor, also known as an LDR sensor. The LDR changes its resistance depending on the amount of light received. The ESP32 reads this analog signal, processes the data, and sends it to the ThinkSpeak cloud platform through a Wi-Fi connection. As a result, users can monitor light conditions remotely and view real-time readings from anywhere with internet access. Now, let's move on to the problem statement. Current methods of monitoring light intensity often require manual observation, which is inconvenient and time-consuming. In addition, users cannot monitor light levels remotely, and conventional systems usually do not provide real-time updates or historical data for analysis. Therefore, there is a need for a low-cost, internet-based monitoring system that allows continuous observations of light intensity. To solve this problem, we established 4 objectives. First, to measure ambient light intensity using an LDR sensor. Second, to connect the ESP32 microcontroller to a Wi-Fi network. Third, to upload the light intensity data to the ThinkSpeak cloud platform. Finally, to display real-time light readings through an online dashboard that users can access remotely. Next is the block diagram of our system. The process begins with the LDR sensor detects the surrounding light intensity. Since the ESP32 can only read voltage up to 3.3 volts, the LDR is connected with a 10 kilo ohm resistor to form a voltage divider. This converts the change in resistance into a measurable voltage signal. The ESP32 then reads the analog voltage from the sensor and processes the data. Based on the measured light level, the ESP32 can also control an LED indicator through its GPO output. At the same time, the ESP32 connects to a Wi-Fi network and uploads the sensor reading to the ThinkSpeak dashboard. This allows users to monitor the light intensity in real time through an online dashboard from any location. Now, I will explain the hardware used in our project. First, we use the ESP32 development module as the main controller. It processes the data and sends it to the ThinkSpeak using Wi-Fi. Second, the LDR sensor detects the surrounding light intensity. Next, the 10 kilo ohm resistor works together with the LDR to create a voltage divider so the ESP32 can read the sensor value. We also use a breadboard to build the circuit and jump wire to connect all the components. Finally, the USB cable is used to power the ESP32 and upload the program. All these components work together to measure light intensity and display the data on the online dashboard in real time. Now, I will explain the hardware implementations of our project. This is the actual circuit built on a breadboard. The main controller is the ESP32 microcontroller, which is connected to an LDR sensor using a voltage divider circuit. The LDR measures the surrounding light intensity by changing its resistance according to the amount of light received. An LED is also connected as an indicator. When the light level falls below the preset threshold, the ESP32 turns on the LED to indicate a dark environment. The ESP32 is powered through the USB cable which is also used for programming and serial communication. After completing the hardware, we developed the program using the Arduino IDE. The ESP32 first connects to a Wi-Fi network using the SSID and password defined in the program. Then it continuously reads the analog value from the LDR sensor. The program processes the sensor reading, determines whether the environment is bright or dark, controls the LED indicator accordingly, and uploads the sensor data to the ThinkSpeak cloud platform. This process repeats automatically every few seconds, allowing continuous monitoring. At the bottom, the serial monitor displays the real-time sensor readings and system status. We can see that the ESP32 successfully connects to the Wi-Fi network and continuously sends the light intensity data to the ThinkSpeak. The successfully HTTP response indicates that the data has been uploaded correctly without any communications error. At the beginning, you can see the LDR sensor connected on the breadboard. The sensor continuously detects the surrounding light intensity. Next, we shine a flashlight directly on the LDR sensor. When the sensor receives more light, it detects an increase in light intensity. The ESP32 then processes the sensor data and sends it to the ThinkSpeak dashboard through the Wi-Fi connection. As you can see, when the flashlight shines directly on the LDR, the sensor detects a higher light intensity. The ESP32 reads the sensor value and immediately sends the data to ThinkSpeak through the Wi-Fi connection. At the same time, the light level on the dashboard increases, showing that the system responds in real time to change in light intensity. This demonstrates that our online light level monitoring system is working correctly because it can detect change in light and update the dashboard automatically. I will explain the result displayed on the ThinkSpeak dashboard. The first graph shows the light level measured by the LDR sensor. We can see that the reading increased when the flashlight was directed at the sensor and decreased when the light intensity became lower. This indicates that the LDR sensor responded correctly to change in ambient light. The second graph showed the light status of the system. A value of 0 indicates the LED is off, while a value of 1 indicates the LED is on. During the test, the graph changed according to the surrounding light conditions, showing that the ESP32 successfully controlled the LED based on the LDR sensor reading. Overall, these two graphs confirm that the system successfully measured the light intensity, transmit the data to the ThinkSpeak, and display the readings in real time. I will present the result obtained from the online light level monitoring system. The system was tested under 4 different lighting conditions. In the dark room, the light level recorded was 27%, indicating low light intensity. When the LDR sensor was covered by hand, the reading decreased further to 14%, which was the lowest value because almost no light reached the sensor. When a flashlight was placed on the LDR sensor, the light level increased to 62%, representing moderate light intensity. The flashlight was directed straight at the LDR sensor. The system recorded the highest value of 84%, showing bright light intensity. This result demonstrates the ESP32 and LDR sensors successfully detected different light conditions and produced readings according to the surrounding light intensity. Based on the testing, the system performed successfully throughout the experiment. The LDR sensor was able to measure ambient light intensity accurately. The ESP32 then transmit the data to ThinkSpeak using a Wi-Fi connection, allowing the light level to be monitored in real time. The system also responded consistently under different lighting conditions. However, there are several limitations. First, the system requires a stable Wi-Fi connection for continuous data transmissions. Second, The speed of data updates depends on the update interval set in ThinkSpeak. Lastly, the LDR sensor may be affected by environmental conditions such as shadows, sensor positioning, or sudden change in ambient lighting. In conclusion, the online light level monitoring system was successfully developed and achieved all the project objectives. The SP32 accurately collected data from the LDR sensor and transmit the readings through Wi-Fi. The ThinkSpeak cloud platform successfully displayed the light intensity data in real time, making it easy for users to monitor environmental light conditions remotely. Overall, this project demonstrates the IoT technology can be effectively applied for real-time environmental monitoring using simple and low-cost components.